Good evening, everyone, and welcome to the Technorama Tuesdays webinar series. My name is Hannah Murray, and it's a pleasure to be with you in pixel form this evening. I am the Student Services and Compliance Officer here at the CMTO. I'm also on the board of Technorama, and I'm here to assist in asking your questions tonight and fielding any technical problems you have. Tonight, we are talking about From Studio to Speakers, the broadcast chain. And we have our wonderful presenters for this evening, Frank Wilcox and Stephen Wilkinson. Unfortunately, Richard Fleming could no longer make tonight's session. We will be having him back for an advanced offering of this session later in the year, but Stephen has very wonderfully stepped in and will be assisting Frank with the session. So if they could turn their screens on, that would be great, and introduce themselves. There's Stephen.
Hi, I'm Stephen.
And Frank is here.
Hi, I'm Frank.
Hi, Frank. Can you go to the next slide for me, please, Frank? So before we launch into the session tonight, I would like to take this opportunity to acknowledge the traditional custodians on the land on which we are recording this session throughout Australia and their connections to land, sea, and community. We pay our respects to the elders past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders peoples today. We acknowledge that sovereignty was never ceded. Okay, so we're talking about Studio to Speakers, the broadcast chain. And before we kind of start the session, I'm going to launch a poll to ask you how familiar or confident you are in your knowledge of the broadcast chain. And I'd like you to answer. It is anonymous. So don't feel that you are putting yourself out there, out to dry. And I'll give you about 10 seconds to answer the poll.
Does that mean if they all know everything, we don't have to do this show?
That's correct, yes. Yeah, that's it. Okay. So still about 10 people to answer the poll. And I'll give you about 5 more seconds. All right, 5, 4, 3, 2, 1. Great. So let's have a look at how we're doing. Can everyone see the poll results? Yep. Yes. All right. Yep. So it looks like we have a good mix of everyone tonight. Shout out to the people that said what is a broadcast chain. And it looks like we are working with mostly a moderate group of people and knowledge. So that's great. Thank you everyone so much for sharing. All right. And with that, I'll pass over to Frank and Stephen. Thank you very much.
Thanks, Hannah. If I can get this PowerPoint to actually work occasionally, it'd be nice. Ah, there we go. There we go. Hi, everyone. How does the program get to the listener's radio? That's basically the broadcast chain. Okay. First, we need a source of program. They're many and varied, such as microphones, turntables. Yes, some stations still play records. That's the vinyl pizza. My station does, 5GTR. CD players, laptops, iPads, USB sticks, and they can be played either through a CD player or there are dedicated USB players I've discovered. Playout systems, satellite reception, and IP sources. These are then connected all to a mixer. Now, either analog or digital. An analog mixer keeps the audio in its, inverted commas, original state, while a digital mixer converts all audio to a digital signal and uses that. Many of the sources have to have their outputs converted to be used by the specific mixer. For example, a microphone or turntable can plug straight into an analog mixer, but must be converted to digital for use in a digital mixer. Similarly, a playout system or an IP source must be converted to analog for use in an analog mixer, but will plug straight into a digital mixer. Now, these converters are known as AD, analog to digital, or DA, digital to analog converters. A lot of the converters actually come with the mixers especially digital mixers. I'm thinking of Axia, where the interfaces come with the mixer as part and parcel of the mixer system.
Yeah, some of them have a what they call a node as to interface or convert it, or some of them have them actually built in. So it's just a matter of plugging in, but it does have to do some form of conversion, as you say.
Yeah. Now, telephone calls, that's the other mainstay of our systems. They're treated differently, as they need a telephone interface. And what that does, that separates the caller from the program emanating from the mixing desk. Now, the program sent to the caller is normally what's referred to as a mix minus signal. Now, this is normally a signal of the whole program without the caller's audio present. That's so the caller doesn't hear themselves. And if they can hear themselves, sometimes it's delayed a fraction that can really throw them off. Sometimes when you hear a caller talking on the radio and they stop because they're listening to themselves on the radio half a second or a second later, and they think, oh, isn't that wonderful? I can hear myself, but it throws everyone because they're not talking. This technique is often used for outside broadcasts and for external contributors, such as sports commentary. They don't want to hear themselves. Now, especially if the codecs are used, the delay can sometimes be quite severe. So the caller can hear themselves milliseconds or even seconds later. And that's quite disconcerting, isn't it, Stephen?
Yeah, that's right. Yeah, so it's important to have the mix minus feed. Because hearing yourself delayed, I'd like anybody to try and do that. Hear themselves and talk at the same time.
Very, very weird experience. Yep. Now, some sources may have processing applied when they're plugged into the mixer, either directly or as a thing called a side chain. Now, direct processing can be applied to things like microphones to improve level control, add compression, or even tailor the frequency response. And normally, because they can operate at microphone levels, they've got an input which will operate at the microphone level and have an output either at microphone level or at line level, depending on the input to your mixer. And sidechain processing, which is applied after the initial preamp. And if you have a look at a lot of mixers, they'll have an in and an out. And that'll take the form normally of echo and that sort of thing. Anything else you can think of on that, Stephen?
No. Just helps keep the level nice.
Yeah, especially microphone processing sounds awesome.
Yeah.
Now, the mixing desk is used to adjust the levels of the various sources. As its name suggests, it mixes the various sources together, and you can turn those sources on or off as they're required. Most mixing desks can do a lot more, such as allowing you to record a source that isn't on air for replay later. Sometimes that's handy. Or you can send a second program for streaming, that sort of thing. And often in the mixer, the off-air program or receive program can be made available for the presenter to listen to ensure that the program chain is fully operational. It's often preferred to have the off-air signal routed to the studio loudspeakers, while the presenter's headphone feed comes from the mixing desk output. And the reason for that is that normally the off-air program is delayed fractionally by processing, especially new processing, which is digital, and it converts analog to digital, and then it processes, and it sometimes has to change it back to analog, and you get a specific delay. If you try and hear those in your headphones and then talk, that will really confuse you.
Yeah, some of those can be anywhere from 12 milliseconds to hundreds of milliseconds, depending on the processing, but also, as we'll go into, depends on the broadcast chain to get to the transmitter as well.
You love the picture of the processor that I've got up at the moment. That's a really old Optimod, but that's an analog processor, which actually didn't have any delay through it at all. Now, the program for the mixer is then connected to the control room or the tech room or whatever you want to call it at your station. It might just be a rack of equipment in a cupboard because there's no other room available. It could even be a rack actually in the studio. The point is, this is where the program from the mixing desk or desks ends up, and maybe from other sources such as other studios and external sources as well. And this is where there is a significant difference between an analog system and a digital system. So let's start with the analog system that I'm very comfortable with. The program will first go to a distribution amplifier. This, as the name implies, allows the program to be distributed to various areas without any degradation of quality. It might be sent to another studio for monitoring or recording. It could be sent to a logger that records everything from that studio, and it could also be sent to a switcher. Now, other studios and sources such as satellite and IP sources might also be wired into the switcher. The switcher determines what goes to air, and the output of the switcher would then possibly go to another distribution amplifier. The outputs of that would go to the on-air processing, more about that later, the program logger, the streaming server through processing if you have it, etc. A bit different in the digital domain, isn't it, Stephen?
Yeah, a lot less wires in the digital domain as well. In analog, there's a lot of cables, a lot of pairs of cables generally. But yeah, in the digital world, especially in the IP digital world, it's generally a Cat6 network cable, and then you're able to route that digital stream to any piece of equipment generally that's on the network.
So once the audio is in the digital domain, as Stephen said, specialized equipment can be programmed to make the audio available anywhere it's needed. Distribution amps aren't needed as network switches direct the audio to where it needs to go. And as they're all ones and zeros, there's no quality degradation. Now from our system comes the point where some decisions have to be made. And these normally depend on how the program is sent out to the transmitters. So if a composite or studio to transmitter link, an STL, is used, then ideally there'll be some sort of basic processing at the station. Now this is ideal, and that protects the link, and the main processing is normally at the transmitter site. There's a reason for that. This is because analog composite STLs are prone to overshoot, and that can affect the loudness of the station and also its clarity. But if you have the processing at the transmitter site, that can often control that a lot better. If a digital studio transmitter link is used, or any other sort of digital delivery system, then the processing can be done at the station, as this type of delivery system isn't prone to any external degradation. You want to expand on that, Stephen?
Yeah, so in a case of some things that I've done is we do the processing at the studios, and then we actually convert the MPX or composite signal to digital, and use MPX codecs to actually send the MPX signal all the way to the transmitter site and straight into the transmitter. So that way there is no analog degradation from an STL, and the advantages of doing your processing at the studios is also that you can inject your RDS, which is the radio data system for now playing data and that sort of thing. You can control all that at the studio, and so then your setup at the transmitter site can actually be a lot more simpler, and also means you don't have this expensive processor sitting at the transmitter side either. So that's an advantage. Yeah,
very much so. And that's the biggest advantage, is to have, also you've got a backup at the transmitter site, which can be done fairly easily if it's digital using a 4G system, correct?
Yeah, that's right. Yeah, you can, and that you can be using over the air, like Ubiquity type 5.8 gig links, but you could also be using internet and even basic ADSL, or as you say, 4G internet at the studio to get your program from the studio to get your program to the transmitter site.
Now, okay, this is just me, but my recommendation is that you should always have a pre-processor to accept the program feed from the station before it either goes to an analog STL or directly to your processor for a digital STL. The reason for that is pre-processing, such as an Aphex compeller, which I've used a lot of times, allows the main processor to nominally operate in its sweet spot. That allows it to perform better and consequently gives you better sound. Still going on with processing, the best way to set up your processing, you have two ears, use them. The ideal thing is to take the manufacturer's recommendations on how to initially set up your processing and then just listen and change one thing at a time and then go back and listen. It's going to take a long time to do it, but if you do it right, you will get the sound you want eventually. And the point is, you will get a sound that you like. There's no black magic in processing. It all comes down to the fact that we've all got two ears. You literally listen to the sound, listen to what's coming out of your studios, and make the best choice you can. Correct?
Yeah, and listening on multiple receivers. Yeah, listening in the car, listening on a radio, in a portable radio, multiple receiving devices, because you really want it to be compatible with whatever anybody is actually listening to your program on.
Now, other things in your control room will be a receiver that feeds off-air signal into your system for distribution to a studio. And this will need a distribution amplifier if it's an analog system, or an analog to digital converter, or maybe you can get a receiver with a digital output. They're available now. There may be your logger set up to record off-air, amongst other sources, so that in the case of a complaint, you have a legal record of what actually went to air. You could have a streaming server with the audio processed if possible, or failing that, take it off your off-air receiver. It keeps your thousands of internet listeners happy. And depending upon your systems, as Stephen will tell you, there'll be other computers that perform other essential tasks within your station. And the reason they're in your control room is because that's normally got its own air conditioner. So, and it's normally fairly quiet, and the only people in there are your techs, correct?
Yep. And yeah, so it's generally you try to make it temperature controlled, as well as the power with UPSs to make sure the power is filtered. And so sometimes, unfortunately, sometimes people can't go as far as having UPSs in their studios for their studio power. But yeah, so your master control is probably the best room in the building.
Well, especially as these days, you can often set something up that if the studios die, master controls can switch over automatically and at least send a program out and keep you on air.
Yeah, and it can either switch if you have automation, switch your automation directly to air, or an emergency program source and put that to air. As Frank said, that the setting up a logger is essential. You need to be logging what's going to air. It's a legal requirement to keep your a log of what's gone to air for at least 42 days. It's an ACMA requirement.
Yep. And you possibly also have one codec somewhere in your master control set up for outside broadcasts with possibly a separate feed from the switcher, so that in our case at 5GTR, we send off air down one channel and we send a mix minus down the other channel. So the announcers know what's coming up, what's playing, but you can also put the off air through a PA system. So at an outside broadcast, you're not worried about reception on your radio. You've got it automatically from the studios. Transmitter sites are not places where people only not go with the appropriate qualifications, as they're quite dangerous places. There's a lot of high voltage around and things you don't know about. Now, the equipment at a transmitter site would normally be an SDL receiver of some sort, either analog or digital, preferably two with an automatic changeover. So if one dies, the other one takes over automatically. You've possibly got a backup feed from the station, maybe through 4G, and possibly an emergency program source, just in case. And if you've got your processor there, which for an analog SDL makes sense, then password protect it, just in case. Yeah. And at a transmitter site, you've got an off-air an exciter and an RF power amp. And if you have a look there, that's the one out of the bluff at Mount Gambier for the commercial station. SAFM as it is now. There should also be an off-air receiver and some sort of speaker system so that you can listen to the program source and off-air sound. Stephen?
Yeah. And also, if you have internet at your transmitter site, you can, there are a number of devices where you could actually receive your internet stream as an extra backup source in case there's an issue with your STLs or however you get your program to the transmitter site. Some of the systems will actually switch across to your internet stream, which, as we know, is not necessarily the best quality, but it's better to have something on air than an emergency program just playing.
Or dead air.
Yeah, or dead air, yeah.
And finally, all stations are restricted to the area they can cover with radio waves by the conditions on their license, which is also why so many stations these days stream their programs so that they can now be heard anywhere in the world. That's about it for the presentation. I think we now go to questions.
Too easy. We've got a question from Mike Tobin. He's written it, but he also has his hand up, so I don't know which he'd prefer. I'm going to ask the question he has written and then let him speak. But he says, we have a feed that comes from an AM station, the audio heavily compressed. This is not optimal for our FM service. How can I handle this?
I would try to get the source from a different site. So even if the AM studios can give you a feed over the MPN or over the internet, would possibly be preferable. The problem with AM, unless you've got a very good receiver, is nominally limited to about 3.5K on current receivers. You would need a 10K receiver and then assume that the AM site hasn't been processed with the massive amount of high frequency boost that they normally do.
Yeah. I'm going to allow Mike to talk because he might have an elaboration on that question. Mike, you'll have to unmute your own microphone. I can't do that part for you.
There, can you hear me?
Yep.
Yes.
Mike, we can.
Is there any point in actually taking it down to raw audio as it would coming out of the console and then treating it for FM compensation to go out on that link? For
sure. You should. That'd be the best way to do it, to process it in another way, and then high quality feed to the FM rather than rebroadcasting the AM.
How are you receiving the AM signal?
From a satellite.
So it's full broadband before they broadcast or after they broadcast it?
They just take the AM feed and feed it up on a spare channel on a satellite, and we take it. But you can hear all the compression and everything. Typical AM station. There in the audio, and of course when that's then fed through the FM processing, it sounds shocking.
Yeah, my question is that before it's being put through to the transmitter? In other words, that feed up to you is still got 10 kilohertz audio on it. As Stephen said, you could then process that separately and get a better sound.
Yeah. We take it off the satellite and then it mixes in through our console and goes on our SCL up to our transmit site.
Right. So
is it processing that separately before it hit your mixer?
Yeah. I think that's what we need to do.
Yep.
Is it possible to get an unprocessed feed from them?
No. We've asked about that. It's not, no.
Yeah.
Thank you, gentlemen.
That's all right.
No worries.
Thanks, Mike. I'm going to mute you now. Okay. We haven't got any other questions lined up yet. If you would like to ask a question to our wonderful panel, feel free to put your hand up and I will allow you to use your microphone to ask a question. In the meantime, my question for you would be, can you explain more about phone hybrids and how that kind of interfaces with the mixer?
Yeah, certainly. A phone hybrid was initially introduced because a phone system is a two-wire system. To send and receive audio through a console, you need what's called a four-wire system. So 2 wires to send audio and 2 wires to receive audio. And what a hybrid did originally with ordinary plain old telephone system lines, POTS lines, was to take that 2-wire system and turn it into a 4-wire system. With NBN and all the digital systems are available now, that has changed quite a bit, but that's what a phone hybrid was originally for. And that's why you had to have a mixed minus sending back, because otherwise the caller would hear you and they would hear themselves, and it would completely confuse them.
Okay.
Does that make sense?
I think so, yeah.
Yeah. And a good hybrid would well and truly null out any difference between the caller and you going to the caller as well. But yeah, so.
Great. What do you think is the most common hurdle for beginners when we're talking about broadcast chain in terms of learning the signal flow process?
Now, Stephen, one for you.
I guess it's good for even for management or even presenters to get a good understanding of levels on a mixer. That's probably what helps the rest of the chain perform well. Unfortunately, too often you see people just put the fader up to the 0 point or whatever where they normally, where they should put it, and not look at the meters on their mixer, whether it's a VU meter or an LED meter. They just look, it can either be very low or it can be way too excessive. And so as a result of either of those options, your poor audio processor is having a lot of trouble coping with that. And that would be partly the reason why Frank suggests having an extra processor in front of, compressor in front of your processor. But a lot of modern processors have AGC control in them, automatic gain control, before they do their multi-band compression. But yeah, if a presenter understands that they need to keep the levels at around the 0 VU, or that whatever the designated digital level is for the facility, then that just helps the broadcast chain to perform to its best operating standard. But just to probably understand the flow that it goes from, the sound goes from the studio to your processor, and then from the processor through to your link, however that is, your STL link, studio to transmitter link, and then ends up at the transmitter and going its broadcast. So that's sort of to have that concept is a big help.
Very much so.
Great. I've got a question from Peter Fitzsimmons. Would you suggest processing/cleaning audio for OB feeds or not, either on-site or at the location pre or post codec?
I would process the audio. If you're going to send a mix minus to the OB site, I would process that audio, because if it's done properly, the local audio would be mixed in at the OB site. If you're just sending off-air program for putting through the PA, which is a full system, I wouldn't process that at all. I seriously wouldn't put off-air through it because of the processing, unless they're using radio mics, which gives a little bit of delay, you're liable to get feedback.
Yeah, I would recommend processing at the outside broadcast if you can. A lot of the codecs now have processing or some basic sort of compression limiting built in, so that what is being converted to is being encoded to send back to your studio is at its optimal level, and then there's no overshoots or distortion, hopefully, that gets ends up getting broadcast.
Yep.
Great, too easy. Question from Evan Wyatt. What method would you use to do a station program level lineup from studio desk to transmitter input? What equipment and reference levels?
Yeah, that's a real can of worms. But personally, if your studios are set up as they are these days, normally for +4, I would firstly check and make sure that, for example, a CD player with a designated test CD gives you 0. Use that as your reference level because that's easy. You don't have to buy equipment. If your VU meters register 0 and you've got a test level, that will give you a nominal +4 output at say 1 kilohertz. You can then use that the whole way through and make sure that your STL isn't overmodulating when you go from +4 and add 8 dB. So +12 should be your maximum. Yeah.
Should also probably use 400 hertz as well, so that you, especially with FM, that because using higher frequencies can, if you're doing it through processor and your stereo generation, well then it adds pre-emphasis. So using 400 hertz gives you a bit more of an accurate level.
Sorry, I'm an AM guy.
Cool. Bruce Lamb would like to know, is there a block diagram available to be able to show our presenters to help them understand with a visual assistance?
I didn't have time to draw one.
Well, do you have a one just sort of handily sitting around somewhere?
No, I don't, but I can put something together and we can put it on the Technorama website.
Yep, too easy. So keep an eye out over the week, and we'll have an example block diagram for everyone to have a look at.
Yeah, it's also the block diagram concept is important to get a hold of that, or an understanding of that when you're doing CBF grants, especially any transmission grants. They usually require you to do some form of block diagram of showing your signal chain. So, you know, from the studio through your processor to your STL and then to your transmitter site. So yeah, so that's important to get a knowledge of that as well.
Yep.
I think that kind of answers Anna's question. Is there a diagram to show the elements from station to speaker? We will put that up online. Tiana Kemp would like to know, what is the best way to check a production desk that has the levels on a screen? I don't really know what you mean there, Tiana. Do you mean that the levels are on the computer rather than the desk?
I would think that some production studios would have, if they've got that, the screen would be integrated with the desk, so that 0 on the screen would nominally be 0 on a desk. That would be my thought.
So she's just said yes on a monitor. Okay. Surely there would be an application that would show you the levels.
Well, you'd think that would be part and parcel of the desk. If in doubt, err on the low side and pull your levels down about 10 dB, because you can always make them louder. It's a lot harder once they hit distortion to bring them down and get rid of the distortion. That's just not possible. So err on the low side, especially if it's a full digital system, you tend to err on the low side. You can always increase the level, correct?
Yeah, that's right. If depends on also the software that you're recording on. If it's something like Adobe Audition or those sort of software, they have level meters on those that are digital level meters. So 0 is maximum and down to minus. So you try to match them with what the desk says so that you know what the meters on your desk, your sound mixer are roughly matching, so that you've got that guide to go by on the sound mixer.
Great. Hopefully that answers your question, Tiana. Question from Scott Mitchell now. With so many from home studios or remote studios taking place during COVID, Should processing be done at remote studio location as well as station end, or would the processing being down just at main studio end acceptable to make sure programs are delivered at best quality?
My answer to that would be, if you're keeping your levels under control, then do the processing at the station. The only processing that would possibly be advantageous in a home studio would be some sort of compression to keep the levels under control.
Yeah, compression or some form of limiting so that you are keeping them consistent. Yep. But not aggressive, so that it's sucks up all the room noise, and as we know, some home studios aren't that great as far as acoustics go, and so if you're compressing them too much, well, when you take a breath or it's a bit quieter, start bringing up the room noise and all the the echo of the room. So just lightly is probably the answer.
Great. I think Mike Tobin has another question. He would like to ask it audio. So I will unmute your microphone for you, Mike. Sorry, allow you to unmute your microphone. You'll have to do that for yourself.
Thank you. Just picking up on something the guy said, one was talking about a 1 kilohertz tone for testing, another one 400 hertz. It's not a bad idea to put both of them through the system for clarity of signal and lack of distortion. That you'll see much easier with two signals going through it simultaneously rather than one.
Sure. Yeah.
Yeah. Thanks, Mike.
Too easy. Another question just before we've got other questions coming up. Can you please explain the concept of codecs to people that might be unfamiliar with what that means?
Codecs in an outside broadcast sense, I guess. Is that what you...
Sure. Yep.
Yeah. Basically a codec is a box that takes audio and converts it to digital, but at a bit reduced quality, like an internet stream. And generally whether it's software or a physical box, you have one at the outside broadcast and one at the studio. And the two boxes connect, and that's how you get audio between the two locations, generally bidirectional as well, which, for doing outside broadcasts. So the term codec, that's what it means.
Great, thank you. Thank you very much. I'm just scrolling through to see if anyone else has any other questions. But feel free to talk amongst yourselves whilst I have a look. It looks like everyone's asked their questions. I'll give people a bit more time, and maybe I will ask another question in the meantime. In terms of getting your signal from the station to the transmitter site, are there any glaring differences between FM, digital, and AM that people should be aware of?
Not getting the program from studio to transmitter. The only difference is on FM it's stereo, on AM it's mono. Basically, everything else can be done the same way. That's the only difference. Having said that, if you have the stereo codecs and you send them to an AM transmitter, you would mono them at the transmitter before you applied it to the excite.
Can you say that again? Sorry, you would mono.
Okay, you can. The only difference is AM is mono and FM is stereo. So you would normally use a stereo link or a composite link that'll take stereo to an FM transmitter. To an AM transmitter, you would use an STL that's only mono. Having said that, if you only have a composite link, you would send both channels, left and right, to the AM transmitter, and you would possibly either mono it before the link, so you'd only use one channel when it got there, or you would mono it at the end of the link at the transmitter end, so you're only feeding mono into your transmitter.
Okay, got it. Thanks, Frank. That's great.
No problem.
We've got a couple more questions. Scott Mitchell, not sure if this has been covered and I missed it. Is processing best to be dealt separately for online streams and the legacy style transmission AM/FM?
Oh, yeah. Very, very different. AM and FM processing has been going on for years. If you're processing to go for your streaming, it's very different. And you've got to allow for the fact that people are listening differently. Correct, Stephen?
Yeah, that's right. Especially, I mean, these days, some of the higher end FM processors do have a separate output or treatment that you can use for streaming. So you can get away with the same processor, but they're generally more expensive processors. In an ideal world, though, you should really be processing your internet stream in a different with a different processor or different type of processing, because with streaming you have to take into account that it is what technically is called bit reduction. So your stream is at a lower quality. I mean, streams can sound very good, don't get me wrong, but it is generally your internet stream is throwing out a lot of information to get that to the person listening on their phone or computer. So you have to process the audio differently for that, in a way that from a listener's point of view, but also from a technical point of view, to allow for that, what we call bit reduction to the sound, and take into account the high frequencies, which you just can't process a stream the same way you would for FM, or even if you're processing for CD production or any sort of mastering production. Your processor needs to be able to take into account where it is ending up and how it's being encoded. So that's an important question.
Yep.
Great. Peter Fitzsimmons again, he would like to know, where would you suggest to get training for technical people where there isn't a pre-existing technician to learn from? What an excellent question.
Good one. I think Hannah can answer that.
I think so.
Oh, thank you. Thanks. Okay, so Peter, give us a call at the CMTO. Our number is 02 9318 9626. I was going to give you my East Side radio station number just then, when you've got the script in your head. But also, if you send an email to info@cmto.org.au, we'll be able to help you hook up with some technical training. Yes, Station Tech for the Non-Technical is a course we offer at the CMTO. We also have courses on Outside Broadcast. Alternatively, if you want sort of more of a mentor situation, if you email us at Technorama, so if you email myself at hannah@technorama.org.au, we'll be able to match you up with a mentor and see if we can get someone to come in and help you directly. So does that answer the question? Is that thorough enough?
Yep.
Great, too easy. Yes. Alternatively, we also have the Facebook group that exists, Community Radio Tech Q&A, which if you aren't a part of, I highly recommend you do become a part of, because any technical question that you could possibly poke a stick at, someone has thought of it and put it on Q&A, and many people have answered it. So keep that in mind as well. Peter has another question, which is, would you suggest running a codec over an in-house VPN for security/direct connection?
That's one for you, Steve.
The short answer is, if you can, that is probably ideal, especially these days in security hacking that can happen even to major organizations. So it's probably so that you're not opening up ports for people to try and get in. The other alternative, if you do open up ports, well, then you're only giving access to the specific ports, but also the specific pieces of equipment. So as long as it's going straight to a certain piece of equipment, like a tie-line codec, then that is a bit more safe. But yeah, a VPN Yeah, would be a great alternative if it works and is stable. Sometimes VPNs aren't always that stable, so that would be my answer to that.
Great. All right. We have run to the end of our questions. So just while people have any more questions, I'll get Frank, if you could go to the second last slide. And I'll spruik our next Technorama Tuesdays webinar session, which is on modernizing your engagement with SMS, social media, and video, which will be presented by the wonderful Bukala Essen from Warringari Radio and Benjamin Erin from 8CCC. It will be on the 27th of April, which is the last Tuesday of the month at 6:30 p.m. AEST, not DT. So if you sign up to that, make sure you can come along. It will be really interesting, and they've got lots of wonderful ideas to share with everyone. We've also got, of course, as I said before, links to Technorama articles, stuff that you can read. There's the Technorama Q&A as well, the community radio Q&A, if you have any questions that need answering. And of course, we're here at the CMTO or Technorama to help you out with any training needs that you have at your station. Just looking at the chat, it looks like that's it for this evening. Thank you so much to our wonderful presenters, Stephen Wilkinson from Hope FM and Frank Wilcox from 5GTR. Is that right?
That's it.
That's it. That's it. Yes. Thank you so much. And thank you everyone for attending. When you finish the session tonight, if you could please fill out the feedback form that comes up. It's integral to us to know what you like from the sessions, what you need, what you want to learn more of, what you think could do better, how wonderful you thought our presenters were, all that stuff. Yeah, and it helps us tailor the content to you. So please fill out the feedback form. And until next time, that's it for our Technorama Tuesdays webinar series for tonight. So see you later and have a great evening. See you next time.
Thanks,
See
guys.
you later. Bye, everyone.